Hello friends, welcome to 𝐘𝐥𝐬𝐬 classes. My name is Professor Vivek Singh Rathore and I am currently Assistant Professor at Government Engineering College Bilaspur, Chhattisgarh. I have done my Masters in Electronics and Communication Engineering from NIT Delhi, and I have cleared many exams which you can see in the screen also. And in this video lecture series I am dealing with signals and system subject. In this subject we are in module number 6 and lecture number 4, that is we are reading Z transform, and we have come to the last lecture of Z transform. From next lecture we'll move on to the next module, and which will be the last module of this whole series. So today we'll try to complete Z transform in this lecture only, whatever how much time it may be. Okay. So in the last lecture we have seen the properties of Z transform, like linearity and multiplication by n, and convolution property, and we have also seen the inverse Z transform. So in this series we'll move on further, and we'll see today some LTI systems, differential equation, difference equations, and how we can make block diagram, direct form 1, direct form 2, and all initial value and final value theorem. So we'll start with some LTI system, block diagram. Okay, we'll study how to make block diagram from given difference equation. Okay, so see, as you know that there is a input to a system, and we take output here. Maybe input is xt, maybe output as y of t, and it has impulse response h of t. This is in continuous time domain which I am talking about. Now let's suppose that same is we have given input as x of n, and we have impulse response of h of n, and we'll get output as y of n. This is in the discrete time domain. Okay, so this system or this impulse response can also be written in differential equation form. You know, mathematical equation which is physically realizable can be more close to the differential equation. Okay, so we'll see. Let's suppose this have a differential equation that a2, let's suppose d2y by dt square is there. Okay, and let's suppose a1 is there, dy by dt, and then a0 a0 y of t will be there. Okay, so this is also y of t, this is also y of t, and in the right hand side if we'll having b1 dx by dt, let's suppose dx t by dt plus b naught, let's suppose b naught x t. Okay, so see, we this is a standard differential equation which we can realize from that impulse response. Okay, so is there any constant term? No, there is no constant term. Constant coefficients are there. Okay, is there any multiple of y and x or y square? No, it's not there. So it can be said as that it is a linear as well as time invariant system. It is a LTI system, pure LTI system. Now this differential equation can be written in difference equation also. See, differential and difference equation difference is that differential equation is written in the continuous time domain and difference equation is written in the discrete time domain. So same to same we can write here like this. a2 yn minus 2 plus a1 yn minus 1 will be there, plus a0 y of n will be there, is equal to b1 x n minus 1 will be there, and b naught x n will be there. Okay, this from difference equation you can write. Now see, if we can take Z transform from it, taking Z transform here. Okay, so what we will get, a2 y of z, time shifting property we can apply, which we have seen in the last lecture. Yz z to the power minus 2 plus a1 y of z z to the power minus 1 plus a naught y of z will be there. Okay, now we can write here as b1 x z will be there, z to the power minus 1 plus b naught will be there, x of z will be there. Okay, this is the differential, this is the z transform of this difference equation. Okay. Can we take common something? So we can take common. See, what I am doing, if you are not getting it, then I will tell you that I am taking a standard differential equation, and this is differential equation is corresponding to a system. It is a system impulse response system or output response, you can say. इफ इन हिंदी आई विल से ये एक सिस्टम है जिसमें x ऑफ t इनपुट दिया हुआ है, h ऑफ t है, y ऑफ t आउटपुट है, या फिर x ऑफ n है इनपुट, h ऑफ n इज अ इम्पल्स रिस्पांस एंड y ऑफ n इज अ आउटपुट. अभी इसका हम क्या करने वाले हैं, इस इक्वेशन को ना मैथमेटिकली लिखने वाले हैं. इस सिस्टम को फिजिकली जो सिस्टम ये फिजिकल है, दिस सिस्टम h ऑफ t, ये जो आपका होगा ये हमारा कोई दिस इज अ मशीन और समथिंग, दिस इज फिजिकल. And if we are writing what this machine is doing in the mathematical expression, that is called a differential equation. So this response we have written in the, this is the standard differential equation response. This can be different, है ना, ये आपके केस में कोई दूसरे question to question it can vary, but for general for making a general block diagram I am taking one a differential equation. I have taken its difference equation, I have taken z transform also. Now I am taking common y of z, so we will get a2 z minus 2 plus a1 z minus 1 plus a naught, है ना, is equal to b1 here we will take, here we will take x of z common, okay, and here we will take b1 z minus 1 plus b naught. Okay, this is there. Now for transfer function, what we can do, y of z by x of z is equal to h of z, because actually h of z only we wanted to take, we wanted to see the z transform of the impulse response, so we can get as b1 z minus 1 plus b naught by x a2 z minus 2 plus a1 z minus 1 plus a naught. This is the h of z, y of z into x of z. This is transfer function in the z domain. Now if you have been asked that this is there, okay, let's suppose total you need output, then what you can do, you can do, see, y of z is there, y of n minus 1, y of n minus 1, and y of n is there. So here also we can take, see, with green pen I will write, if you need only y of n, what you can do, y of n, so obviously all this term will be going to left hand side, right hand side, so I can write minus a2 by a naught, y n minus 2 will be there, okay, plus minus a1 by a naught, y n minus 1 will be there, and plus b1 by a naught, x n minus 1 will be there, plus b naught by a naught, x of n will be there. See, this equation which I have written in this green color, you can see this is the output response. See, we have seen a differential equation, we can do difference equation of that, and now for a discrete time LTI system, we what is y of n? Y of n is output. Output is nothing but just we have shifted in the right hand side, so we got this one. Now see, you see what output is dependent upon, y of n minus 2 means previous second output है ना, y of n minus 1 just previous output, x of n minus 1 past input, x of n present input. It is not dependent on future input, it is dependent upon either present input, past output only. Okay, so present input, past output, past input also. Okay, so these three terms in which y of n is dependent. Now we will try to realize this one. Actually what we need, we from this equation we can realize or make block diagram of a system. So see, I will write here, let's suppose I will write here again, y of n is equal to, I will write again the term a2 by a0, y of n minus 2, okay, minus a1 by a0, y of n minus 1 here, and plus b2 b1 b1 by a naught, x of n minus 1 will be there, and plus b naught by a naught, x of n will be there. This just only we have calculated. Now we'll see how we can make block diagram from this equation. Okay, so see, y of n is the output, so we'll try here. Y of n is the output, we'll make it like this, and here is input, x of n will be the input is there. Now only in between what is impulse response we need to make it. So how we'll make it? See, y of n is the combination of all these things, no? X of n is there. Now x of n, see, x of n is directly sent to the output with multiplication of this coefficient. So we can write, see here, like this, and we can make b naught by a naught. Just we have multiplied with x of n and we have sent to the output, okay. Okay, and only this term is not there, na. We have to add this term also. So maybe we can do one delay factor. One delay factor will be there. One delay factor, let's suppose one m, I will write m for delay. Okay, it will just this output is nothing but x of n minus 1. It will just delay something, है ना, whichever input is there. Now x of n minus 1 is there. We need to just multiply with what signal? b1 by a0, and we need to add also, na, because both signals are added. So there will be a addition signal here. Okay, we'll keep like this. Okay, so here left hand side we got, right hand side y of n is there. You can tell that y of n, y n minus 1 is also there. So one multiplication factor will do here, so that we can get y of n minus 1. But here y of n minus 2 is also there, so one more delay factor will be coming, so we'll get y of n minus 2. Okay, now what will happen? See, this combination will come on, and again some combination will come on. Which combination? See, y of n minus 1 will be there. Y of n minus 1 we can take here, and we can multiply with y of n minus 1 is minus a1 by a naught, and we can add over it, है? And here also y of n minus 2 will be there. Y of n minus 2, here also some addition will be there. We can keep y of n minus 2, so minus a2 by a naught, so we'll keep minus a2 by a naught, and we'll add it, है? So see, this is the block diagram which is formed with this this equation. How this equation came from this difference equation, how this equation came from this differential equation, how this equation came from physical system. So a physical system can be realized in differential equation to difference equation to equation of y of n, and which can be realized by this block diagram. So this block diagram is the physical realization of the this difference equation. So this is actually the original system which we see in the plants and all. This input is there, output is there. What is in between? Some delay factors are there, some multiplication factors are there, some addition are there, and then just we'll get output very easy. So see, as we know cumulative property. Cumulative property says that see, let's suppose x of n is given as input, है ना? And if we are having, let's suppose h1 of n is there, and then h of 2n is there, h of 2n, है ना? And we get output as y of n. So as you know that what will happen, x of n will x of n convolution with h1 of n convolution with h2 of n will be the output, which will be the output. So according to cumulative property, anything can be replaced, interchanged. So we can also write it as x of n can be here, and we can write h2 of n and convolution with h1 of n, and then we can get as output. So this can be interchanged. So see, actually this is what you are seeing now. See, first of all, you understand that this can be interchanged. Which can be interchanged? See, if you see this block diagram, we can see that this portion and this portion actually, you know, both are there, so it can be interchanged from left hand side to the right hand side. So see how we can do it. We'll plot here x of n will be there, okay. And now see here what we were doing. We'll put this right hand side to the left hand side, just opposite. So see what will happen. This x of n, this delay factors are there too, we'll keep here. And then this plus sign is there and this plus sign is there, so we'll make here like this. See, just follow it, plus is there, okay. And then delay factor, two delay factors are there. Let's suppose m is there and this is m is there and this is going on. So earlier what used to happen, see, uh, this combination is there, okay, this combination is there, and all things are there, just you need to make this right hand side in the left hand side. So here one more combination is there, so he will make one more combination, and here some value will come. What value will come? See, m value is there, m, and here minus a1 a0, hai na? So we can plot here as minus a1 by a0, and we'll give it to this. And here also one combination is there, we can see the combination minus a2 by a0, so we'll make it as minus a2 by a0, and we can just put addition over it, hai na? So the right hand side thing comes on the left hand side, and I'll tell you why we are doing it, why like this we are doing, why it is not sufficient, so it is not good. So this also left hand side will go on right hand side, so as it is we'll make it like, see here one m was there, so here one m will be make okay, m is there, one combination is there, so combination will make it like this, and we'll make it b not by a naught, है ना? b naught by a naught value is coming. Now here in downside b1 by a naught is coming, so we'll make here as combination, okay. So b1 by a naught will be there, and both are added, है ना? Both are, I think in here both are added, so I'll make it here as both are added, and we'll get as output y of n. So see what happens. See, this block diagram and this block diagram is very equivalent, nothing is there, just what we have done. See, all are addition only, so ultimately we can put here or we can put here, no problem with that. So ultimately output will come the same thing, so we can do like this also. The this is actually direct form 1. This type of block diagram is called as direct form 1 block diagram, okay. This block diagram is called as direct form 1 block diagram. It is direct relation between differential equation and physical form. Actually, what was your differential equation and what is physically present, this is physical, है ना? And differential equation is mathematical, so it is a direct relation between your physical and mathematical expression, okay. So see, this is direct form 1 block diagram, nothing is there, just you have done equation is there, you just have plotted it, and you can do left and right whatever you want. So this is the direct form 1 block diagram. Now I'll tell you, see, this is going on like this. So there is one delay factor, so we can, what we can do is, see, both are taking same input, so we can merge it and we can make one only this delay factor. So now we'll go for direct form 2, which will deal with, see, will merge things, like, see, first of all input is there and one addition is there, and your minus a1 by a naught is there, here minus a2 by a naught is there, m is there, here m is there, and b1 by a naught, just same as that of. So I will make here here x of n will be there, x of n, one summation sign will be there, okay. It will go on and it will have one delay factor, okay, and one more delay factor is there, okay. And then it will have some some multiplication factor, that is minus a1 by a0, and here uh, minus a2 by a0 will be there. Okay, now it will be added here. Okay, plus sign will be there, and then it will be added here. Okay, fine, and here it will go. So, and in the right hand side it will go on like this. Okay, b0 by a0, and then it will go on plus sign, and here also one more will go on like this, b1 by a0, and then it will go on here, and this is y of n. See, the difference between this portion and this portion is only thing that we have merged the delay factors, so that the requirement for delay is less, है ना? How much machine or how much units will add, so much cost will also increase and complexity will also increase. So we can merge and we can put only one, then it's sufficient. So like this we can put, this is called as direct form to block diagram. I will write here direct form to block diagram, है ना? Or it is also called as normalized block diagram, है ना? It is called as normalized block diagram. Okay, okay. So see, generally for research and industry, this only the second direct form 2 is used because it has some common things and less requirement of delay factors than this. So direct form 2 is going on, is currently used, and research is also going on. So see, I'll tell you one question I will give you, and then try to solve this question and we'll try to understand. See, one question is there. Uh, this is x of n is there. Okay, x of n, and there is a plus sign, and then it will go on. Here again plus sign is there. Okay, and here this is minus 2, and here minus 3 is there. Minus 3 is there, and then here delay factor is there. It will go on again, delay factor is there, go on, and again here 2 is there, and then again here 3 is there. Okay, this will go on adding, this will go on adding, and this will keep y of n. See, now it is from here you can see one delay factor is there for common both, so it is a direct form 2 block diagram. And what we need to do, we need to see its impulse response in z domain or in time domain also you can see. So see, first of all, by seeing the block diagram you need to write the difference equation. So see, we'll write the difference equation of this block diagram. Okay, so we'll write, see, y of n, y of n, y of n will be equal to, y of n will be equal to, see, here what will happen, here delay factor is there, y of n, it will come y of n minus 1, and minus 2 will be there only. So we can write minus 2 y of n minus 1 will be there, minus 2 y of n minus, and here minus 3 y of n minus 2 will be there, minus 3 y of n minus 2 will be there. Okay, now here it will go on, so 2 of x of n will be coming, so plus 2 of x of n will be there. Okay, and plus if you'll see x of n minus 1, 3. Okay, so 3 x of n minus 1 will come here. So see, from block diagram we have we can make the difference equation, and from difference equation you know that it is very easy to calculate the z transform. This is y of z. Okay, this is minus 2 y of z, z minus 1, minus 3 y of z, z minus 2, and plus 2 x of z will be there, plus 3 x of z will be there, z to the power minus 1 will be there. Okay, now see what will happen. Y of z can be taken as common, y of z will be there. Here 1 plus this will go in left hand side, 2 z inverse, plus 3z to the power minus 2 will be there. Here x of z can be taken as common. 2 plus 3 z inverse will be there. Okay, so y of z by x of z uh, is equal to h of z will be there. H of z can be come as 2 plus 3 z minus 1 and 1 plus 2 z minus 1 plus 3 z minus 2. So here if you multiply z square on both numerator and denominator, what we'll get? We'll get as 2z square plus 3z, 2z square plus 3z, and here also z square plus 2z plus 3. This is the final answer or h of z of this block diagram. Very easy, very easy. So you can see one thing I will tell you apart from this question, because this question is solution is this much only, you can understand this question. Now see, what you need to see, causal. If you plot h of n also from this equation, what you will need that first of all you will do partial fraction and then we'll classify and all so much things are there. So what we can do is one trick is there, that whenever the degree of denominator and degree of numerator is same, okay, I will write here degree of denominator is equal to degree of numerator, then system is causal. Okay, this point also you can remember. So this will be a causal system response. Okay, and the delay factor, see, I was telling you this was m. Okay, so if you are giving input as x of n, it was taking a output as x of n minus 1. So what is this m? What is this delay factor? So see, when a input x of n is given, when it will come as x of n minus 1, what will, when it will come? So see, its z transform will be x of z will be x of z only, है ना? And its z transform will be x of z z to the power minus 1. So if you will take output by input, you will get h of z, है ना? H of z will get output by input, so you will get xz into z minus 1 and xz, so you will get as z minus 1. And whose z transform is z minus 1? Delta of n minus 1. Delta of n minus 1, if you will take z transform, you will get as z to the power minus 1 out in z transform. So ultimately this delay factor is nothing but delta of n minus 1. So wherever I have written this m, okay, this is nothing but delta of n minus 1. Now we'll move on further and we'll see some more property of Z transform. We'll see time differentiation property. Okay, time differentiation and time integration property. We'll see time differentiation property. Okay, so see, as we are in Z transform, we are talking about discrete time signals. So let's suppose x of n is having Z transform of x of z. So if we'll do differentiation, you know, in differentiation for in discrete time, how we'll write x of n minus x of n minus 1. Like this we will write differentiation in time, okay, in discrete time. So in the output what we will get, see, x will take x of z as z transform, here x of z into z to the power minus 1. So it can be written as x of z into 1 minus z inverse. Okay, see, as you know, in Laplace transform, what we have seen, if x of t Laplace transform is x of s, so d by dt of x of t, it will be s into x of s, if you remember. So here also, if something is multiplied by x of s, here also something is multiplied by x of z. So ultimately you can compare these two. I will write in I'll show you in time integration property also. I'll show you. Okay, so see, I'll write time integration property. Time integration property. Time integration property means that, let's suppose x of t, in Laplace I will tell you, Laplace transform x of s it was coming. If we'll integrate minus infinite to t x of t dt, so and we will take Laplace transform, we will get x of s by s. This in Laplace transform you have seen. Now see, we'll see if x of n z transform is x of z. Okay, so if we'll integrate it, x is equal to k is equal to minus infinite to infinite x of है ना, x of, let's okay, I will take n only, and x of n. Okay, so if we'll integrate x of n from n is equal to minus infinite to infinite, we'll take z transform. What we'll get, x of z by 1 minus z inverse. Okay, 1 minus z inverse. Actually what is happening, see, any signal is when integrated with integration, so what is happening actually, x of n is nothing but integration means convolving with u of n. Whenever a signal is, see, here also we'll see x of t convolve with u of t, then you'll get minus infinite is equivalent to infinite to t x of t dt. Okay, the same way here also, so it can be written x of z into u of z. U of z is nothing but 1 by 1 minus z inverse, so we have written. So you can see again the similarity here. If you take integration, you are getting 1 by s common term, and here 1 by 1 minus z inverse term. So ultimately from both equation you can see that the thing s in Laplace transform is equivalent to 1 minus z inverse in z transform. Okay, in Laplace transform. In Laplace transform, whatever s term we were talking about in the Laplace transform, it is equivalent to 1 minus z inverse in the z transform. Okay, now we'll see, as we have seen in the Laplace transform, that there are two variants of Laplace transform. The same way we'll see the two variant of Z transform. The variant which I am talking about is bilateral Z transform and unilateral Z transform. Okay, so I'll make it here. See, bilateral Z transform means that whenever we need to calculate Z transform, what we are doing, we are taking from n is equal to minus infinite to infinite f of n z to the power minus n. This is the formula by which we are taking Z transform, but this is Z transform of bilateral, because we are taking the values from n is equal to minus infinite to plus infinite. And here for unilateral Z transform, if we want to take Z transform, so what we will do, we will take n is equal to 0 to infinite. Okay, will not take any negative value, will take only from 0 to infinite f of n z to the power minus n. This is the unilateral Z transform. Okay, so as we have seen in the Laplace transform also, the same thing here. See, this will have multiple Z transform expression for a single means what we can say. See, we can a to the power n u of n, and minus a to the power n u of minus n plus minus 1 will have the same Z expression, only differentiated by their ROC. So here we can classify two signals based on the ROC, otherwise Z expression will be same. But here there will be no ROC, because here the expressions are anyway unique, so we did not have to mention. There will be a region of convergence, but we don't have to mention it. We don't have to mention, because there we have to mention, because two signals can have same Z expression. Here it won't happen. We'll take some example and we'll try to understand. Like see, earlier we have seen if our f of n is 1, you can understand 1. Okay, every value will have every value will have the value 1. Okay, every value will have the value 1 from minus infinite to infinite, this value. But see, this is equivalent to 1 is equivalent to nothing but u of n will be there. U of n means from n is equal to 0 to infinite, and from u of minus n minus 1 will be there, which will start from minus 1 and it will go to minus infinite. Earlier, in bilateral Z transform we used to have, for this we are talking about bilateral Z transform only, so we can treat as 1 minus Z inverse, and here we can treat as minus 1 by 1 minus Z inverse. Okay, just opposite of that. So obviously it is coming 0, so Z transform was not defined for this value. But for unilateral Z transform, it will be u of n plus u of n minus 1 minus n minus 1. So actually, so see, for unilateral Z transform, no negative values are taken, so this value will not be taken, so only 1 will be equal to u of n, which is equal to 1 by 1 minus Z inverse. So ultimately 1 will have Z transform as 1 by 1 minus Z inverse. And see, this is for unilateral Z transform. This will be for unilateral Z transform, nothing more than that. Again, I'll give you one question. Let's suppose, see, a to the power n u of n is there. Its Z transform, first of all, understand this is equivalent to a to the power, let's suppose mod is there, a to the power n u of n is there. Okay, and here we can say a to the power minus n u of minus n minus 1 will be there. Okay, so ultimately what you can write is, see, for bilateral, so okay, we can write here 1 by 1 minus a Z inverse. Okay, and here we can write 1 by 1 minus 1 by a Z inverse will be there. Okay, and negative sign will come here. But for unilateral Z transform, obviously this term negative sign will cancel out, this term will negative will cancel out, so final answer will be 1 minus 1 a Z inverse. So this will be the Z transform for this expression for unilateral Z transform. So I think you can understand what is bilateral Z transform, which we calculate from n0 to minus infinite to infinite. And whenever it is said as unilateral Z transform, or in the question ROC is not mentioned, then you can understand that it has been taken as unilateral Z transform. Okay, so see, now actually it is very useful in some of the questions, like, see, we'll see in time shifting property, it's used in the time shifting property. Okay, time shifting property, already we have seen that if f of n Z transform is f of z, then if we'll do f of n minus 1, we'll have Z transform as f of z into z minus 1. Actually this property we have seen for bilateral Z transform, but for unilateral Z transform, your f of n minus 1, see, for unilateral Z transform, your f of n minus 1 will have Z transform of f z z minus 1 will there, but some initial value will also occur, because see, unilateral will start from n0 to 0, so some initial value will also start, so f of minus 1 value will be also taken. Like, see, if we will take f of n minus 2, okay, Z transform, so we'll obviously will get fz into z to the power minus 2, which is the normal bilateral, but we'll have some initial value like f of minus 1 will come, and z to the power minus 1 will come. Okay, and then we'll have f of minus 2 will come, it will go on decreasing, and it will go on increasing the power minus 1 0. Okay, so it will cause f of minus 2 only, till that the z value is 0, till that will go for like this. So like this type of expression is called it will be there in the unilateral Z transform. So you'll ask, sir, where do we use this type of question? So I'll tell you, one question will try to understand where do we use like this. So a discrete time LTI system is given, and its difference equation is given. Let's suppose equation is 3y n minus 2 is there. Okay, and it is minus 2y n minus 1 will be there, okay, and then plus 4 y of n will be there, and then is equal to x of n will be there. Now see, this difference equation is given. Find you what you need to find the response. You need to find the response. You need to find the response of this system. Okay, you need to find this response of this system, and input has been given in the question. Input is given 3 to the power n, u of n is given, and some initial conditions are also given. Initial conditions are also given, like suppose y of minus 2 is equal to 3. I think you must have solved this type of question in the mathematics also. And y of minus 1 value minus 1 value will be given is equal to minus 2. So see, now difference equation is given. You need to calculate the output response. Input is given, initial conditions are given. See, this type of questions, y of n minus 2 can be converted in the Z transform, but see, when initial conditions are given, just remember it, when initial conditions are given, you don't have to take just only Z transform, bilateral Z transform. You need to take unilateral Z transform because initial conditions are given. So here what will take, 3 is there, okay, y of z will be there, z to the power minus 2 will be there, plus y of minus 1 will be there, and z to the power minus 1 will be there, plus y of uh, minus 2 will be there, and z to the power 0 will be there, okay, and this will go on. Then minus 2 y of z will be there, z to the power minus 1 will be there, plus y of minus 1 will be there, and z to the power 0 will be there, okay. It will go on, plus 4 y of z will be there is equal to x of z will be there, okay. Now see, we have considered the initial condition. You can see 3, we can take y of z will be there, z to the power minus 2, plus y of minus 1 value will be there, it is minus 2, minus 2 z minus 1 will be there, plus y of minus 2 value 3 value is there, minus 2 y of z value will be there, z minus 1, plus y minus 1, its value is minus 2, so we'll write minus 2 है ना, minus 2 value, okay, and plus 4 y of z value will be there and is equal to x of z, okay. So see, this you can easily classify, है ना, yz one disha, yeah, I will do it, okay, yz we can take common, yz we can take common, so we'll get 3 here, 3 z to the power minus 2, है ना, 3 z to the power minus 2 we got, okay, and here minus 2 z minus 1 also we got, plus 4 also we got, this is y of z, है ना, this is y of z, and initial condition are minus 6 z inverse we get, plus 3 is a 9 we get, minus 2 and minus 2, plus 4 we get, okay, and here is equal to x of z will be there. So ultimately what we got, y of z value will be equal to x of z is there, plus 6z inverse, 6z inverse is there, okay, and here plus 13, it will go in right hand day, so it will be minus 13, and we can divide as 3z minus 2 minus 2z minus 1 plus 4, 3z minus 2 minus 2z minus 1 plus 4. See, you can understand that this portion is having involving x of z, and this portion is not involving any x of z. X of z is nothing but your input, है ना. So output will have component of input part and some non-input part. Actually this portion is called as zero state response, because here no initial conditions are there. This portion is having no initial condition, and this portion is having no input condition, so this is called as zero input response. Means this portion is part of response and it is having no input, that is why it is called as zero input response, and this is called as zero state response. Zero state response, okay. So see, see, zero input response. Zero input means we have not given input, and it is output is dependent on some initial conditions. So zero input response is also called as natural response. So whenever you have been asked any question in the exam, calculate the natural response, you need to calculate the zero input response. Okay, zero input response. And this one, it is having input portion, means there is input given and then output is coming, so it is also called as forced response. Okay, this is also called as forced response. So you can understand that this forced response is zero state response, also zero input response, or we can say it as transient response. Okay, transient response. When we have given input, we were giving input, some output were coming, we have suddenly removed the input. So what is the property of that system? That is actually without input, that is natural response, or we can say transient response, hai na? And this is your forced response, ZSR. Okay, so okay, so finally what we can conclude is total response is the sum of zero state response and zero input response, in which wherever input portion is there, that is your zero state response. Here no initial conditions are there, that is why that is state, zero state response. And here some states are there, it is not having input, it is called as zero input response. So here we have completed this portion. Now we'll see the last portion of the Z transform, last theorem of the Z transform, and then we'll close this Z transform. So we'll see initial value and final value theorem. Initial value and final value theorem we'll see. See, okay. See, first of all, I'll revise you that when in Laplace transform, how we have taken in. See, initial value and final value is nothing but in time domain, what is the initial value and what is the final value. This is initial value and final value theorem. So, see, in Laplace transform, what we have done, if we wanted the initial value, what we used to do, we used to do limit s tending to infinite s of fs. This we used to do. And for final value, what we used to do, limit of s tending to 0 s of fs. Now see, we have seen that for this theorem to be valid, the numerator portion should be less than denominator portion. This was the condition. And for final value, the condition was the poles of s into f of s should lie in the left hand side of the s plane. This was the main condition for this. Now as we have seen till now that whatever s is there in the Laplace transform is equivalent to 1 minus z inverse in the z domain, in the z domain, Laplace domain and z domain. So here see, now we'll talk about in z transform how we'll do it. Okay, so we'll see in the z transform. Okay, so see, so we'll see Z transform of in Z domain, how we'll do it. So there is no light in my house, so I may my face would be appearing dark. So let it be. You should understand the concept. So see, this is the initial value theorem and final value theorem in S domain. So what we'll do is we'll f of 0 means initial value, it will be, see what will be limit value. See here s tending to infinite, s value is tending to infinite, it means sigma plus j omega value is tending to infinite, it means sigma is tending to infinite, it means r to the power r is equal to e to the power sigma is there. So if sigma is equal to infinite, therefore r is tending to infinite. If r is tending to infinite means z is tending to infinite, mod z. So we can tend as z tending to infinite value, है ना? And s into fs, s is nothing but 1 minus z inverse is there into f of z will be there. Okay, f of z will be there. So one see, this is the initial value theorem for in z transform. It can be also calculated by other expression, like see the same expression like this. See 1 minus z inverse, 1 minus z inverse means 1 minus 1 by z, है ना? So 1 minus 1 by z is there. So if you'll keep z value infinite, so what you'll get 1 minus 0 value. Okay, 1 minus 0 means 1 only. So directly, or you can write limit z tending to infinite f of z, f of z. So this value can also be taken as initial value theorem, this value can also be taken as initial value theorem. So both statements can be written. It depends upon your expression, how your expression is there. Okay, I will tell you one question, then you can understand how we will take it. So see, this is your initial value theorem. For final value theorem, how you will take? See, final value is nothing but f of infinite value, है ना? F of infinite value in Laplace, what we will do? S tending to 0, s into f of s is there. Okay, so now what we will do is we'll put it, see, s is tending to 0, it means sigma plus j omega is tending to 0, it means sigma is tending to 0, it means r is equal to e to the power sigma means r is tending to 1, है ना? So we can write here limit z tending to 1, s is nothing but 1 minus z inverse into f of z. Okay, so this is the final value theorem for z transform. This is the final value theorem for z transform. Otherwise, one more statement is there. See, 1 minus z inverse, it can be 1 by 1 minus z inverse means 1 minus 1 by z is written, so it can be written as z minus 1 by z. Okay, so see, if you can write here in downside z is equal to 1. So because see, if you'll write 1 z value 1, so 1 minus 1 0, ultimately all will come 0, no final value. Like this it won't happen. That's why we can put z is equal to 1. So directly we can write limit z tending to 1, z minus 1 into f of z. Okay, this also expression is valid for final value theorem. Again, I will tell you one more expression for final value theorem. See, you can write this expression also, z tending to 1, z minus 1 by z also, because see 1 minus 1 by z is z minus 1 by z into f of z. So this expression is also valid. So all three expression is valid for your final value theorem. Only you need to understand the condition in which this is applicable. Okay, so for z transform initial value theorem, you don't have any conditions at all, but for the final value theorem your condition is there. Final value theorem condition is that, see, whenever your like that of s of fs is, the poles should be in the left hand side in the Laplace transform. Here the condition is, condition for final value theorem, final value theorem is that 1 minus z inverse into f of z. Okay, remember this both multiplication and then which is there, all the poles of, all the poles of 1 minus z inverse f of z, all the poles of 1 minus z inverse f of z should lie inside the unit circle. Okay, so all the poles should lie inside the unit circle. This is the one and most important conditions for final value theorem. If the poles lies on the unit circle or outside the unit circle, then your value, if I'll write, if the poles lie on the unit circle or outside the unit circle, then final value will either be undefined, है ना, either will undefined, or final value theorem, uh, then final value theorem must not be applied, this condition you should remember. So we'll solve one question and you can understand this theorem. We'll solve one question. Question is that, see, f of z is given. F of z is given. Let's suppose z minus 2 is given, z minus 3 is given, z minus 1 is given, z minus 1 by 3 is given. Okay, now you need to find initial value theorem and final value theorem. Initial value and final value. Initial value and final value you need to calculate. How you will calculate? By using the theorem. So for initial value, what we'll do? See, limit z tending to infinite, 1 minus z inverse into f of z will be there. Okay, so or you can also write it as limit z tending to infinite f of z value. So how we can do it? See, f of z is given, है ना? F of z is given, so f of z can also be written as 1 minus 2 z inverse, 1 minus 3 z inverse, 1 minus z inverse, and 1 minus 1 by 3 z inverse. Like this also you can write, and whenever you'll put z is tending to infinite, all values will be 0 only, so ultimately value will come 1. So initial value of this f of z is 1. Final value, for final value what you need is z tending to 1 minus z inverse f of z 1, see whichever fits over it. So for z minus, it is also equivalent to limit z tending to infinite, z tending to 1, z minus 1 by z into f of z, or it can also be written as limit z tending to 1, z minus 1 into f of z. This three may say any one you can write. So I think the third one is more significant. If we can cross z minus 1, z minus 1, so ultimately we can write limit z tending to 1, z minus 1 into f of z. F of z is nothing but z minus 2 is there, z minus 3 is there, okay, z minus 1 is there, and z minus 1 by 3 is there. So z minus 1, z minus 1 is cancelled. You can put the value z is tending to 1. So you'll get 1 minus 2 is nothing but minus 1 into 1 minus 3 is nothing but minus 2, 1 minus of minus 3, so 2 by 3 will come, so it will be it will cause, see, minus 1 minus plus 2 to cancel, so answer is 3. So final value is the 3 value. So very easy, you can understand that how we have calculated the initial value and final value theorem, है ना? Now we'll see one more question and then we'll close the session. So second question. Now this will clear your mind about initial value and final value theorem. Again, you need to find the initial value and final value for the given z expression. F of z is given in the question. F of z is given. Z minus 2 is given. Z minus 3 is given. Z minus 1 is given, and z minus 4 is given. See, the last expression we have z minus 2, z minus 3 is given, z minus 2, z minus 3, z minus 1 is there, but z minus 1 by 3 is there, and here z minus 4 is there. Only difference between the last question and this question will have this value change. So we'll see whatever values are changing. So we'll solve the question. Okay, we'll solve the question. We'll see limit z tending to infinite. If we'll keep 1 minus z 1 minus uh, z inverse 1 minus z inverse 1 minus z inverse f of z. Okay, this value can be put in, so we can do z or we can directly put limit z tending to infinite f of z value, and then again we'll put the values. What we'll get 1 minus 2 z inverse, so ultimately we'll get 1 1 1 1, so final value will be 1 only. So initial value you have got earlier also, the values were same 1 only, here also 1. So we have not got anything change when we have if we'll put z minus 6, z minus 7, or z minus 99 also, nothing. It will initial value will come 1 only, है ना? Initial value will come 1 only. For final value, you'll keep limit z tending to 1, 1 minus z inverse f of z also can be put in. We can put limit z tending to 1, z minus 1 by z fz also can be written, and limit equal to limit z tending to 1, z minus 1 into f of z can be written. Any three of the can be written. The most important thing is, if z minus 1, z minus 1 we can write, then we can put the value. So we can put limit z tending to 1, z minus 1 is there, and the fz we can write z minus 2, z minus 3, है ना, z minus 1, and z minus 4 is there. Okay, see, if you z minus 1 is cancelled, so you'll keep limit z tending to 1, so 1 minus 2 will be there, 1 minus 3 will be there, and 1 minus 4 will be there. So you'll get minus 1 into minus 2 by minus 3, so you'll get as 2 by 3, है ना? Minus 2 by 3. If you think that this is the answer of final value, then you are wrong. This is wrong. Why this is wrong? Because I already told you that whenever any pole of z minus 1 into fz, z minus 1 into fz means z minus 1 into fz, if you have cancelled also, you are getting one pole at z minus 4, means z is equal to 4. It is outside the unit circle. So I told you the condition that final value theorem cannot be applied when poles are outside the unit circle. So this condition you should remember. So see, these all conditions were for initial value and final value theorem, and here comes the end of Z transform. So almost in the fourth lecture I have already almost completed the every property and standard Z transform for standard signals, what are block diagrams, how we'll plot it, and then initial value and final value theorem. So we'll meet in the next lecture with new module, that is DTFT, and then we'll study DFT also, phase delay, group delay, and all will be covered in the last module, which will be in the next lecture. And I think not more than four or five lectures are required now. So we'll see in the next lecture. If you have liked this video, then do hit the like button, share it with the needy students, and if you have not subscribed, then do subscribe it for getting the latest notification. So till then, tata, bye bye, see you, have a good day, Jai Hind.